You know I don't like JSON. The quotes, the commas, the curly braces, it's just too much clutter. I especially don't like JSON when I call an API and I get an output that looks like this. What is this? I don't know. I normally write a Python script to parse this and make sense of it for me. But recently, I discovered a command line tool called JQ. JQ processes messy JSON data like this, and it allows me to understand what the data is much more easily. Let me show you what JQ can do with this JSON. If I say JQ and then put this dot and then pass in the JSON data, which right now is in this file, boom, instantly, I now have better spacing, better indentation, and syntax highlighting. This version is the same JSON data, but it's much easier to read. It is a lot to scroll through and understand, but that's okay. JQ has many other features that let me dissect this object to get to the parts that I really want. Today I'll show you how I use JQ to process JSON data, and later on I'll show you some resources if you really want to level up and become an advanced JQ user. Since we're getting warmed up, we'll look at JQ with a much smaller JSON object that looks like this. First, when you think of JQ, think of it as a series of filters operating on a stream of JSON data. JQ receives some input JSON data, it does something to it, and then it outputs some more JSON data. Those filters in the middle can do anything. It could extract some piece of information from the input, it could manipulate the input JSON, whatever you want it to do. The most simple filter is something called the identity filter, given by this dot. When JQ sees this dot, it knows to just take the input JSON and output that same JSON in the exact form. Well, that's not quite true. We saw that at the very least, it pretty prints the JSON, but the actual content of the input JSON is the same as the content of the output JSON. Which then leads to the question, well, how do I get the input JSON to the JQ tool? Well, there are two ways. By default, JQ will read from the standard in channel when looking for an input stream. This means that we could take our data that is right now in this file called schools.json, and if we cat that file and pipe it to the JQ tool, JQ will be able to read that data from that input stream. We of course have to pass in a filter, and if we run this, we get that pretty printed JSON output. The second way is to use a file name. If the JSON already sits in a file, then we can pass that file as an argument to the JQ tool. We say JQ, and then the filter, which is a dot, and the name of the file where that data lives. We get the same output as a result. I personally prefer using this file-based method of passing data to JQ. But if I'm building a bash pipeline, then obviously the standard in approach is the way to go. All right, this use of JQ gets you pretty far. Just using the identity filter alone gets you a human-readable output of the JSON. But of course, there's much more you can do with it. Let's say that I want to compact this for export. Well, I can use the JQ tool and pass this -c flag, C for compact, and that will output the same JSON using the identity filter, but this time it will minify it, removing all those extra spaces and indentation. Cool. Let's check out some more filters. We already saw the identity filter given by dot, so we can say JQ.schools, and we get the same output back. Whenever you see this dot, just think of that as this object, or the current JSON object in the input stream. We can extract items with different filters. Suppose I want to get this value tied to the key of school. Well, I can modify my filter so that I have, instead of dot, a dot school. This tells JQ, hey, I want to go to the key of school and pull out the value that is tied to that key, if that key exists. And I get the result of Hogwarts. Similarly, if I wanted to get another key of students, I could pass in, instead of .school, .students. Note that this is a JSON array. There's open brackets and closing brackets, and within the array, I have 3 objects separated by these commas. But sometimes I want to unpack the array so that I have separate JSON entities as part of my stream. That can be done using the index operator. After the student's key, I can pass in this opening and closing bracket, and that will unpack the items into separate JSON entities. Notice that now there's no opening and closing bracket, and there's no comma between these objects. These are 3 distinct JSON objects in a stream. That will be important later on. The same bracket notation can also be used for indexing and slicing an array. For instance, if I want to get the second item in the array, I can put the number 1 within the bracket. Like Python, JQ uses zero-based indexing. The first item has an index of 0, the second item has an index of 1, so on and so forth. Running this, I now get the second object in the student's array. But this might be a little bit too much information. I don't want to know the house, the year, and the owl count. I just want to know the name. Well, I can start stringing together identifiers. If I just want the name of the second student, I can simply add a .name to the end of that, and now I get just Hermione Granger. Notice that this output is a JSON string. It's got those double quotes around it. There are times that I don't want a JSON string. I just want a simple string that I can pipe to another command line tool. And if that's the case, I just use the -r flag, R for raw, to take the actual JSON content and emit a raw version of it without those JSON quotes. Oh yeah, I forgot to tell you about slicing. Again, you can use a single number to get one item from the array, but if you want a range of items, you can use slicing using the colon. For example, if I want to get every item from the first index to the end, I pass in 1 and then colon. Or if I want to get the very last item in the array, I can pass in negative numbers, specifically a -1. Slicing here works a lot like slicing in Python. All right, let's camp out more on this student array. Let me pull that back up. I need the students from our file. And let's suppose that I want to find out how many objects are in this array. Kind of a silly question. Right now I can see there's 1, 2, 3 items, but for a large array, I don't want to count them manually. So I would do something like this. I would first extract the student's array and then pipe that to another filter called length. And that's right, you can chain together different JQ filters. Basically, the output of one filter becomes the input for the next filter. This command is saying, get the student's key, whatever the value is there, pipe that to the length filter. And the length filter, unsurprisingly, gives you the length of whatever array or object is passed to it. If I run this, I get the answer of 3. Sometimes I want to filter my JSON objects and only hold on to the ones that are interesting. For example, I might just want the students that are in the house of Gryffindor. How would I do that? Well, I type in the JQ command, and then I access the students by using the student's key, and I have to unpack that array so that I get each student individually. For each of the students, I then need to determine, hey, am I going to keep that student or not? And one way of determining that is using another filter called select. The select statement expects some kind of logical statement to determine which students are allowed to pass into the output. In this context, I want students that have a house value that is equal to Gryffindor. So I'll say equal to Gryffindor, close the parentheses, close the quotes, and of course pass in the data. And now I have my 2 Gryffindor students. But this is a little bit too much information. I don't really care about the year and the owl count. I just want to know their names. So I could take this and pipe it to a third filter. And for this filter, I'm not going to use a function in the JQ tool. Instead, I'm going to create my own JSON object. That's right, you can create your own JSON object by passing in curly braces or anything that's valid JSON. Right now, I just need to know the person. So I'll make my own key called person. And for the value, I'm just going to pull the value that's tied to the key of name. So I'll say .name to indicate for this object, pull out the name. And as a result, I get 2 different JSON objects with just one key value pair. I can create any kind of JSON object. I might just want to keep name as name, or create a key of name that pulls from the value of name from the original object, and then maybe introduce a new key value pair. I could say I have a new key of magical and a value of true, which is a JSON valid item, and we would get this as the output. This pattern of extracting items from an input JSON is so common that there's actually a shorthand that JQ allows. If I just want to pull a particular key value pair from the input JSON, I don't have to repeat this name dot or name colon and then dot name. Instead, I could just use name by itself with a comma at the end, and JQ will know, okay, you want to create a key called name, and for the value of this, you just want to pull whatever the value is for the input name. So here are 3 examples of how you can create new JSON objects based on the input stream. You can create your own keys and reference values from the input stream. You can create your own key value pairs on the fly. And there's also a shorthand form if you want to extract specific key value pairs from that input stream. Time for my favorite subject, math. JQ has arithmetic operations as well. Let's look at that student's array again. Let's suppose that someone does something mischievous and lowers the OWL counts for these students. How is that done in JQ? Well, I start with the JQ tool, and then I access the students using the student's key, and I'll unpack that because I need to perform some manipulation on each item in the array. I'll pipe that to another object where this time I'm creating a JSON object. I want to know the name, so I'll put in name, and I'm going to manipulate the al count in some way. I'll say al count for the key and then a colon, and here's my new value of al count. I'm going to reference the old value of al count by using .al count. Remember that dot represents this object, and I'll subtract 5 from that. Then I'll close my curly braces for JSON, close the quote, and pass in the data. And ooh, Hermione's probably not so happy. Instead of having 10 owls, she now has 5. We, of course, could be more generous. Instead of subtracting items, we could add, let's say, 15. And this is how we can add and subtract to individual values in a JSON stream. Here it's not too exciting, we just have 3 objects, but imagine having thousands of objects, and this little bit of code reaches into individual JSON objects and changes the value. In addition to addition and subtraction, JQ has the normal operators you might expect. You can perform division, multiplication, exponents, anything you might think of. All right, we've looked at a lot, but this was a simple toy example. In the real world, we don't have small pieces of JSON. Instead, we have long, messy pieces of JSON with thousands of objects, much like what we saw at the beginning of the video. So for the remainder of the video, I'll show you how I would use JSON for a real API response that has multiple characters that are hard to make sense of. Just as a reminder, the API response looked like this. And if I'm trying to make sense of it, this is how I would do it with JQ. First, I just need to get a high-level understanding of what is in this JSON. So there's a filter for that called keys, which just emits the keys that are available in each item of the stream. I'll pass in the JSON object, and I now see that there are 3 keys, the data key, the links key, and the meta key. As a data engineer, the part I'm most curious about is data. So I might then go into the data object, or the data key. At this point, I see that the data key has a series of objects in an array. But this is still a lot of information, and I don't want to scroll through all of this. It looks like it keeps going. Well, next, I could figure out how many items are in the data key by piping that to length, and I now see I'm working with 100 different items. But these items have a lot of extra information. I just want to know the name of the spells. I don't need to know the URLs or who made the spell. I just need the names. To do that, of course, we can access our data key, unpack it, and then just reach into the attributes key and then the name key. So I'll type in attributes.name, and now I have the name of all the spells. Great. If I look back, I notice that these spells also have some kind of category, and I'm curious about what are these categories? What do they represent? Just like before, I can reach into the data object, unpack it, access the attributes, and then access the category. And I see, oh, there are some repeated items. It looks like this category could be used to group together different spells. And now I'm wondering, what are all the categories that are present? Let's build a filter to do that. I'll say JQ again, and this time I will wrap my categories that are output here into an array to form an array, and I'll pass that to another filter we haven't looked at called unique. This takes an array of items and essentially deduplicates it so that I have unique items at the end. So here are the unique categories, and I can already see that there is an opportunity for some data cleanup. Here I have Jinx that's capitalized and Jinx that's not capitalized. Nice. Let's look at one more example. When I was looking at the data, I noticed something interesting. Let me show you. Each of these spells has some kind of light, some kind of color of light that's emitted. And I'm now curious, well, okay, how many of these spells here emit the orange light? Well, I'll start with JQ again and build my filter. I need to go into the data key, and this time I need to extract any object that has a light of orange. A new filter for doing that is something called map. Map takes in some array as an input, performs some kind of logic, and then emits another kind of array. In this context, data is already an array, so I will pipe that to the map filter, and map is expecting something that you want to do for each item in the array. In this case, I want to select specific spells, specifically those that have attributes dot light equal to orange. And I'll close the parentheses. So what is this saying? Let's look at this together. The .data filter tells JQ to reach into the data key, which in this case is an array. That array is being piped to the map filter, and the map filter is going through each item in the array and applying some function to it. The function in this context is select. So for each item, we're going to select it if its attributes.light key is equal to orange. And this is one way of figuring out how many spells have a orange light. Well, actually, I do need to figure out how many, so I'll pass this to the length to figure out the length of the output array. And of course, pass in the input JSON, and I figure out there's only 2. Out of the 100 spells here with all the extra information here, JQ has now identified that there's only 2 of them that have an orange light. And I can keep going. This just scratches the surface of what JQ can do. JQ is a full-fledged language. It can allow things like variables. It has conditionals like if-then statements. The sky's the limit. And the best way to figure out what you can do with JQ is by going over to the documentation at the JQ website. I'll link that in the description below. All right, that's all for now. The next time you're working with JSON data, give JQ a try. And until next time, happy coding.